Hello. Okay, so next session, which was about edge use cases. Have you guys been to an OpenStack Design Summit session before? They're called PTGs now. All right, congratulations. This is your first. I'm only talking to you if you're in the front row of seats. There will be no microphones. I don't care if you sit up in the back of the room and play on your laptop or whatever you're doing, but if you want to be part of the conversation, you must be in the front of the room because microphone passing it around takes too long. So, so far, well, it's just us. That's nice. No, so I'm like totally serious. If you want to be involved in the conversation, you have to actually get up and move because I'm going to make the guys turn off the audio in about 30 seconds. All right, so one of the things that came up yesterday was we were trying, basically the Nova people in the room were trying to work out what the use case for this thing is. Like, is it Comcast set-top boxes, or is it like a one new box in Walmart that's driving their local print and point of sale, or is it like a half a rack? I don't know, wherever you'd put half a rack, like Devon Anders' company, or is it like 5 racks? Like, the way you deploy OpenStack for those things is completely different for each of those use cases. And so if you look at the Etherpad, that second line there is the URL to the Etherpad. So we were kind of doing this a bit yesterday. The idea is people keep notes there as we go along with the conversation. So all I've done is I've brain dumped a list of all of the kind of deployment sizes that I can think of. I don't work in the telco industry. I might be completely wrong. It's a straw man. The point is, if I do something deliberately wrong, then it's easier for you to tell me how it's wrong. Does that make sense? Like, I don't know, maybe 0 people in the universe have interest in managing set-top boxes with OpenStack. That's cool, we'll cross it off, but I don't know that until you tell me, right? Paul-Andre, do you want to do your thing?
Yeah, sure. All right. Can you hear me well? I'll use the microphone for a while. My name is Paul-André Raymond. I work for Beyond, and I'm also co-chair of the group that's the FUG Edge Massively Distributed Cloud group. It's a team now of OpenStack, and that's a group of people that involves INRIA, it involves people from Red Hat, it involves people from FBK and people from Beyond. I hope I didn't forget anyone. Ericsson will join soon. And a lot of the topics that have been discussed yesterday, we have been addressing for the last several months. So if you're here and you're interested in those topics, you please go onto the Etherpad for the FAMDC group, join in the discussion over there, and pitch in. In the last few years, there has been a lot of activity in trying OpenStack and massively distributed, doing some real tests, and verifying that a massively distributed OpenStack really works with 1,000 nodes. There's been some work in trying to improve the database to actually work in a massively distributed way. And that work is ongoing at the moment. What kind of database do we need beyond MariaDB? There's work going on around the message queue and what kind of message queue do we need to massively distribute. And also there's a big stream around use cases. In the Etherpad here, there's a link there to a presentation that we've been debating, and some of the topics that were discussed yesterday are being discussed in this presentation. Have a look, bring some comments. The way Michael has broken down the question here in terms of what kind of edge nodes we need is a question that we were trying to address, and hopefully we can move further in this discussion today with your collaboration. So that was my pitch for FEMDC. Any questions or comments?
You mentioned that massively distributed. You mean like single OpenStack region distributed, or like multiple regions?
Well, that's one of the questions. So do we want to use one monolith OpenStack? Do we want to have OpenStack distributed as multiple regions managed with a single central node? Or do we want to use Nova cells and distribute OpenStack as Nova cells? Or maybe the edge nodes are some just remote compute nodes, and that's another architecture. Which one is it? I don't know. Is it just one? Probably not. So that's really is the discussion that we should have. And depending on the detail of your use case, what service scenario you're looking at. If you're looking at a VCPE application the way Verizon had it yesterday, then you get to one answer. If you look at a 5G use case, the way AT&T were talking about it in one of the sessions yesterday afternoon, then you have it at a different answer in terms of how big is the node, and how do you implement OpenStack over that? And do we need, and are there some improvements needed in OpenStack? I don't think we need new features, but there probably are some improvements that are needed to make it work better.
Well, let's have a practice run. All right. So like I said, no microphone. They're recording this because they're contract required. We're going to make them throw the video away later. All right. So first example deployment. Who wants to manage their set-top boxes with OpenStack? Anyone? Sorry? With OpenStack. Who is Comcast with 100,000 or a million or whatever it is set-top boxes and they somehow want OpenStack those? No one? Maybe a little? Okay. I can't scroll. You can be my scrolling man. Scroll. Okay, so next size up. Who has some sort of deployment that looks and feels like a 1U box? Whatever the biggest 1U I can buy from Dell is today, so it's probably got 30-something cores, 100 gig of RAM, and I'm going to put a bunch of virtual machines on it. I don't really care what those things are doing. Okay, that's more common. Cool.
Sorry, I didn't raise my hand for small edge device because I was assuming that I would not run OpenStack, but instead I would run RDE for Docker containers.
Oh, right, okay, yeah. Sorry, let me rephrase. Who wants to manage their set-top boxes with OpenStack somehow? OpenStack isn't necessarily on the set-top box, it's just a victim of OpenStack. Okay, cool, sorry, all right. So a few, all right, that's cool. So if we rephrase the 1U example, how many people want to manage some 1U box out there in a right page with OpenStack?
Why with OpenStack? I mean, like, I'm not raising my hand, but when you say with OpenStack, I might experience it because I want to manage half a million set of boxes at the end. But I think not OpenStack.
Right.
That's cool.
That's cool, but this is a room with OpenStack developers run
No,
on the
this is
OpenStack Foundation.
OpenDev. It doesn't have to be specific to OpenStack.
I can fix that.
Me too, actually.
Because this is an OpenStack event, I guess.
I guess.
Like, I don't, if you want to use Kube or something else, walk down to it's completely fine with people making great things on them, but I can't tell you how Kube works because I've never used it.
I
Is
think,
there a specific reason why you would not use OpenStack?
I think this is an event for for people who are interested in OpenStack applications. But some people are thinking that OpenStack are not needed for small edge devices, although we may run OpenStack for all cloud and so on. But some small devices with just a hypervisor may complement OpenStack-based for infrastructure.
And that's totally cool, right? Because what I'm hearing from that is if you said, set-top boxes are not really going to do the OpenStack thing for that, but maybe the regional data center, that's cool. I'll stop thinking about this use case, and when people program features of that use case, I'll say, show me the user, because we've never met them before, right? What we're trying to do is, at least in Node, maybe it's not true in other projects, is we have a whole bunch of random people show up on our menu and say, I desperately need this is the most important thing we possibly ever do for OpenStack. Not picking on AT&T, but like the presentation this morning, yesterday morning, right? The number one thing the OpenStack community should do is cloud. That's cool because we can't find anyone who wants to use that. Is it really the number one thing? So what we're testing is this actually a thing people want to do? Sounds like set-top boxes, maybe not.
So if for me, if as long as OpenStack can scale out to this level as 1 million, I think for the small device that should be fine.
Okay.
With that clarification, I will say on all 4 of your possible device sizes, I can think of use cases where you would
No,
He told me not to do that.
All right. Well, I can't.
No. Yeah, it's because you've got to within 5 feet.
Didn't hear you say it.
Saying you came late. Did you get instructions?
Yes, Michael.
Yes, I would say that all four of your use cases, I can conceive of situations where I would actually want to use your term, I would like that device to be ubiquitous. Yes.
Okay, cool.
So the first with the set-top box one is set-top box is a compute node, right?
It could be a compute node, so I'm
If it's not a compute node, I don't care about it. That's what I'm trying to figure out.
So the point right here, the session is not, no one thinks of it just for edge computing. The session is use cases for edge computing, which might include also the server.
Right.
For example, if I have a big potentially orchestrated as mobile LXC, which is completely disconnected as a storage, and I'm using it as a storage endpoint, which is, by the way, exactly what I use around
That's pretty.
well, it's up there. But literally, that is the set-top box too. Now, that particular use case is very similar to what secure wants to do. So you got a set-top. Okay, I'll turn around because I can't see any of those. Set-top box is wall-mounted thing, which is
Okay, so picking on that example for instance, so you might choose, I don't know, I think you go and take the example about this. So, the set-top boxes might be a device managed by our You want to know if it's powered up. You want to know if they checked in recently. You want to occasionally push a new image to them, but that image itself does not contain any OpenStack. Right? So sure. That is the thing OpenStack can do now. I don't think it scales to a million in a single ironic form, but hey, we can talk about that, right? So what we're trying to do is validate, like if nobody actually wants to do that, then we can cross it off and something like that class problem, right?
So maybe I'll address it from a different side to say, why do I want to do this? Okay, I have applications where I can conceivably running in a data center, running somewhere between the data center and edge. And I would like to have a common set of APIs by which I can say, this application there goes. That's the reason why I'm saying OpenStack. I can do this with Kubernetes or these other things. But I'm looking at it as a way in which I can manage it. So there's another conference somewhere where we're going to have the exact same conversation with Kubernetes. But I think there's still use for an edge device, which is a compute, which is orchestrated as the victim of something.
Okay, so let's move on a moment. So it sounds like all four of my examples are probably things that you're interested in. Alright, so the next question is, are my assumptions about those examples correct? Like, so set-top boxes, full internet connectivity, drops in and out, that sort of thing. Well, I come from Australia where fastest DSL I can get in my house is 4 megabit, right?
Yeah.
So, what's your target customer for these remote and set-top boxes? Are you just going to say, nobody with 4 megabit DSL can buy my TV?
No, sorry, that's not what I'm saying. So in your smallest one, you said if there is no internet connection, the device is not yet operating. Okay. In the very first one. I'm saying that even a device which is intermittently connected is perfectly usable.
Okay, so the device is a thermostat.
Because the device is going to do some local processing and potentially it's not going to be able to give mommy at home an instantaneous reply. And the next time the network comes up, the packet will go across and it'll say something happened 15 minutes ago.
Alright, cool. So that's 60 okay. Because I don't even remember what I set up there.
You said the CPU is not functional or you're connected.
Yeah, because I'm thinking streaming TV use cases, right? So if that's not true, we should just use the I'd scrolled off because you've rage quit. Good job.
I can go scroll again.
I also don't want to spend the whole session focusing on micro devices, is what I decided to call them in my old age. But like, for example, with the micro things, I can think of 3 ways to do that now. And in fact, during this conversation, we thought of 4. The point is that none of these examples
in terms of use cases, one aspect of maybe that is not there. If we focus on that micro edge device still, how often would you want to do OpenStack validations on that device? How often would you want to update the VNF? How often would you want to collect metrics about what's going on?
Okay, so rather than beating around the bush, I'll give you a practical use. Okay. Literally.
That's a stand up around the level.
Raspberry Pi.
Great.
Okay. Raspberry Pi. Running connected to a camera, connected to my stable network, running TensorFlow. TensorFlow is running. Can you use the microphone? Michael.
We're not doing that.
Oh, fine, you can use the microphone. All right, yes, just you. No one. It's a slippery slope. No, use it. No, because.
Go ahead. No, I like it up here.
Okay, so camera connected to Raspberry Pi, running TensorFlow.
You have to hold the microphone to your face.
Running TensorFlow, and whenever it notices a pattern, a picture which it doesn't recognize, it reports that picture, and I get an alert on my phone. Periodically. That is running in a VM, and your question was, how often am I going to restart this VM? Probably once every 3 days when the thing kind of hangs itself, or spawn a new thing. How often do I push a new image? Well, when I have new patterns, because this is supposed to be learning stuff. So the moment I find a new pattern, I will push that pattern down. How often will I do that? I have no idea. I'm building a prototype. The thing is going to be connected not on a wired network, but it's an IoT device. When it can get a packet across, it gets a packet across, period.
Yeah, so, but that's a good enough answer, right? We're talking about orders of magnitude. The answer is quite infrequent.
Like
Once every few days.
yeah.
Yes,
Yeah, not every 10 seconds.
correct.
Or it might be when like the customer orders a new feature for their set-top box, like home security thing. They put a thing, could be every 6 months or something.
But on a set-top box, it might be, they do something every couple days.
Yeah, that's what he said.
Yeah.
I got it.
Yeah,
But
it's
it's
still-
not 10 minutes, it's not 10 seconds.
It's still extremely infrequent, right?
Anybody has a different use case?
I'd like to say frequency is not the only factor. For example, when we run security devices in Raspberry Pi, when we want to update the security process, we have to update the process instantly. So it's not just about frequency.
How do you do
But,
that if the backhaul is offline?
well, in such cases, of course, we will keep up. But when the device is online, we would like to update the software as soon as possible. So the frequency is not the only factor.
You mean the latency between having a security patch and being able to
Yeah.
install it? Yeah.
Yeah. So that's not really a design constraint for OpenStack, though, right? What we're trying to do is work out how to size the control
Well,
plane.
it depends. If they're rolling out the security patches, deleting an instance and creating a new image, then that is a whole big storm of instance previews.
Right, but security patches are usually, we update a couple files.
Not for people that are doing ephemeral image-based, containerized chunks of
Yeah,
functionality.
OpenStack doesn't support changing a couple of files inside your VM.
Right.
Well, OpenStack doesn't, yeah. But you would access it directly, the VM directly.
If you're
That's an implementation choice. So what I've actually been doing for the last 2 years is working with one of the world's largest banks on their Hadoop clusters. The way they deal with this problem, admittedly a different problem space, is they've got Hadoop workers. If one acts weird, they just re-image the thing with the golden image. If they've got a security update, they just roll it out to 10,000 machines. It's flattening all over, and I would do it with set-top box exactly the same way. I don't want to change a couple of files because what if that doesn't work properly? I just want to re-image the whole damn thing so it's in a known state. Which I imagine is probably how it works now.
Well, VDI is frequently done that way. So like lab machines, call center machines, you just load down a standard image that
Yeah, exactly.
sits down every morning.
Especially because set-top boxes are probably, stateless, right? You're not storing photos of your cat on a set-top box. Any stuff that you've got is a cache or something that's remote, I would assume. You can't trust the set-top box to exist tomorrow.
Even if you are, hopefully that's not part of the image of your
so you're thinking like streaming TV, set-top boxing thing, so a Roku or whatever. Maybe it's got a local cache band for instance, and most people like to watch that. But if that thing fails, you go to the store. If the person gets you a new one, the first time you plug it in, it says, "Who are you?" You say, "I'm Fred," and it downloads everything that you want. So it's effectively stateless because the state is in the file.
It's restored.
Yeah, the state is not
Part of the application
valuable.
image.
The local state is not valuable, right? Yeah.
But even so, to use that example, you can perfectly well operate a device like that and make it stateless by saying, assume that it's stateless, and therefore you will push state periodically, and anything you haven't pushed in the last 15 minutes, now you can use it. If there's learning on that device, whatever you've learned in the last 15 minutes,
I feel like we're picking on the set-top box case a little bit because I don't remember how long the session is, but
Next.
so it just gets bigger from here, and I think as it gets bigger, it actually gets easier, right? Like if you need to consume an entire CPU core on a half rack of machines, you can run OpenStack. Probably don't care. I think the other thing that changes is your expectations of the reliability of connectivity. As the deployment gets bigger, it's more likely that a person in a truck is coming to fix it than the fiber breaks, for example. Like, if it's some sort of regional data center with diverse fiber parts, one is unlikely to go offline, and two, if someone's writing a national newspaper article about it already, and there's trucks deployed, kind of thing. So you can start making more assumptions about reliability. But maybe I'm wrong there too, because I'm not a telco person.
I could talk about the small edge devices. So,
Sure.
yeah, I'm a technical person. So there's a huge demand for this particular edge case. Typically, like the coffee shops, literally I had one of those coffee shop vendors, which by the way called Quick Marts in the industry, and I didn't know either. The guy literally told me, he says, the box is going to be sat next to an oven. So it has to be ruggedized. So the other thing is that there's kind of they want very low cost, obviously, because these are coffee shops. But they also want they also do need fairly high reliability. So some of them do HA, some of them don't. So that's something to consider in this. Because some of them are like bank branches, for example, will do HA, but coffee shops may or may not. Because you have to see, well, can I afford to be down for a couple hours?
But what's the app? Is it the music the store's playing, or is it my point of sale?
The point of sale is going to be high up, but if they do the point of sale so that if the network goes away and they do a store and forward, they're okay.
Yeah.
But the application still has to be run.
The application still has to be run.
So is this Neutron NOAA network enough for that, or do you still need Neutron here for the reliable stuff? No, NOAA net, is it sufficient?
So Nova Network is deprecated. Anybody who is about to deploy Nova Network now really seriously needs to come talk to us. But it is not yet deleted.
I guess here Nova Net, not neutral.
Yes, because I think I'd probably use Nova Net and I can come have a conversation with you about it.
Or some skinny version. Yeah, we need a skinny version of it.
So NOAA net doesn't exist right now, right? Everybody has left NOAA net. Everybody's on Neutron. So why are you saying NOAA net?
Michael is saying he understands the model of Nova Network.
Oh, okay. So it is.
In case it was available, but it's going away. So.
It's going away. So Neutron, whatever it is.
But it sounds to me like what is we need a lightweight version of Neutron.
Light Neutron. Okay.
Yeah, so
Microneutron. Call it microneutron or something. Yeah. Okay.
what I'm trying to say is we have decided that people don't want a super lightweight network and thing like Nova Net and we're going to delete it. If that's wrong, it would be super great to tell us that because either we should solve that in Neutron or not delete Nova Net.
Well, I think we should solve it in Neutron because you want to post it.
Can I ask a question about the meeting scope? So this looks really, really good at getting these different use cases documented. Are we actually trying at this meeting to document gaps? Is that part of the goal, or is that too much for trying to get?
It would be nice, but really the object of the meeting is to capture capture the use case and the requirements at some level. Now, what I intend to do as part of the Edge group after that is take those use cases and then start implementing them and doing some measurement and verify that they do indeed work at scale.
So Mark, yeah, one of the things I think is like Michael was able to come up with a couple of ways to implement all of these with existing stuff, which is cool.
Sorry, I
But
guess we can
yeah, yeah. So the point is if like half the room is really interested in this case and specifically the one that OpenDev is the right option, even though it's a thing today, if everybody is like kind of looking at that as a desired case, then that's not a gap yet, but
I got you.
Well, and there's some implementation in there. So we have NovaNet versus Neutron because we say that we've implemented it as a region. But we could implement this in some other way. I mean, why isn't that the Nova Cell instead of an OpenStack region?
that's why there's multiple implementations of each one.
Yeah.
So, you want to drill into that question of why your region is not enough? So, as a failure to be, if this thing is going to be intermittently connected or periodically disconnected, whichever way you look at it, I'd rather have it be its own completely functioning entity with its own OpenStack and its own research, its own whatever.
But if it's disconnected, you're not going to do any management anyway because all management is done
It
remotely.
depends. So if you have a branch office, right, that's going to have a bunch of compute, and even if it gets disconnected from the central office, there's got to be some application that might need to still be spinning things up, spinning things down, or handling stuff. You can't really use a Nova Cell for that because you need to have a fully functional environment that's got an API and can deploy and delete things while the main connection is on. If you don't need that, if the only things that would change the environment would ever come from outside the branch office, then it's probably fine to put a cell or less there.
I'll give you a specific example. I want to have each running there, and they will run even when the network happens to be on.
Exactly.
And I would like some automation, which I, for myself, to be able to do a new stack command. Even for
Little
the
scale or something like that.
scale, even for the 5 minutes when the network happens to be down. But you know what? Some remote operation is trying to push a new image down there. The network's off. It's going to retry. It's going to get expensive. That's the reason I'd like to have a region.
Yeah, I think it's a good example, right? So let's pick on someone new now. I'm Walmart. I've got half rack of machines out the back. I don't know, the internet connectivity's down, but that I don't care because I still do point of sale and inventory and stuff. And now it's stock take season. And suddenly I turn on 200 barcode scanners and people go and scan every barcode in the store. I probably will use something like Peak or some sort of auto scale which scale up the inventory system.
Yep.
And then scale it back down because it's all got rid of database. And that's all local. It doesn't matter that the internet connectivity is down. When it comes back up, then go tell it quick before it's hot to put in a truck and send it, right? And so you probably want to completely OpenStack your half rack. Frankly, the half rack, a couple of cores on OpenStack is probably not that big a deal. There's probably 800 of cores at that point.
Yeah. But, let's say you want to get that down from half a rack down to 2 boxes.
Yeah, but you wouldn't be doing an inventory with hundreds of barcode scanners at that point.
Well, you wouldn't be doing localized scale up and scale down for 2 boxes.
Right.
most
No, you
likely.
can't.
So that's totally fine to optimize away having a full OpenStack there and have it be dependent on central office.
Right.
Yeah, and like if you're Starbucks and you play the wrong Christmas music for a day and you fail to push the data,
It's not a big
no one
deal.
cares, right? No one died. It's the wrong type of pumpkin spice song. Is there a pumpkin spice song?
Moving to the next one.
Sure. I'm a terrible person and I'm not a telco person, so I'm using Australian telco terms. You're very welcome. So NBN is our national broadband network. The way it's built is there's a fiber to the node cabinet on your street corner. This is a simplification, of course. And that person talks to a POI, point of interconnect. And then those go and talk to regional data centers. And the scale of those things changes. So a POI would be my local exchange. The nodes are wired to fiber. And then those go and talk to some sort of data center, one per city or whatever. The scale up here and those things will change because our exchange is probably the size of a garden shed.
So I can add another instance. And again, this comes from experience with customers asking for this. This is the situation where a customer has a couple data centers and they want to put in some cloud services in these data centers. So they're relatively small data centers. They might, they have 3 or 4 racks. And so that's the medium deployment situation. So they have regional, they might have 5 or 6 around the globe. And that's a very common scenario.
Yeah, so the medium and large also feel a bit like CDN nodes to me.
Yeah.
CDN deployments, right? Half a rack of YouTube caching. I want to manage that stuff. I don't want to think about individual machines anymore.
Yeah, and again, if it's a CDN intermediate location, the whole point of it is to be able to react to demand, right? And so if that node is disconnected, you can't push the content there to be cached anyway. So it might not matter that that thing is completely independent of itself. Therefore, it doesn't need to be a region because you can't get the cached data to it.
So, yeah, this is an interesting question. The question is being disconnected from the network the same as being disconnected from any central point of control? Can those two things happen independently of each other?
Yes.
And yes, I would go with they can. To take the blind previous example, if I start updating things, then disconnection is going to happen for a period of some variety. So it's better to think of this thing as simply not having a leader for a time, rather than thinking about it as being completely unwired from the network.
Yes, and the workload will stay running, right? So if the workload is static and unchanged and can still provide to the CPE what is currently there, then that's cool. But if you can't update the workload, you can't get the new data to it anyway. So it doesn't necessarily need the control plane to be autonomous on that thing if everything comes from the center.
That may well be true, although it hasn't to be microphone design is one where it can be at least reactive to problems, responsive. So you've got control plane locally, but if that's a call, you can make that judgment call.
That's the distinction between this and the Walmart case, right? The Walmart case, even if it's completely isolated, it still needs to be able to scale up and scale down internally because it's got heat running at the store. Versus if you don't need the cabinet on the street corner to scale up and scale down itself because it would be scaling up would need data from
Let's
external.
be clear on the scale, right? Particularly in network services, we're not scaling up and scaling down dynamically on demand because the capacity of this unit has to be big enough to satisfy its maximum demand. Scaling is not a thing. But what is a thing is reacting to failures or faults.
I actually disagree with you, by the way.
Okay?
Yeah, so I've actually had a coffee meeting with the telco in Australia. It's like, you can work it out in the context. We're deploying these cabinets on every street corner in Australia. We've deployed extra gear so that our stuff is redundant. When that gear is idle, we want to lease the idle space to Netflix.
Okay.
And so their primary box for doing all whatever it is that they're doing fails. They murder all the Netflix stuff and move their workload.
Yeah, I was going to say that's...
They do effectively have spare hardware.
You've managed to basically find the one thing that makes us agree with each other, which is I'm saying that's there for repair, you're saying that's there for scaling. So kind of thing.
So you're talking about a use case where the primary workload is network function virtualization. What if I'm actually doing word processing? In this case, there's a barcode scanner. 200 people walking the store with barcode scanners. You need more things to record the data and do something with it.
Yeah, that's true. But on the other hand, if you're limited to a local data center, then you need all the capacity.
Well,
The switching mode is the significant thing. Capacity remains the same, but I switch my emphasis.
no, the switching mode is exactly the same thing here. The workload which is being put on that device is changing. During the day, it's for the same device. In the evening, it's people doing it in different applications getting to come up and downward. The only use cases that moving packets from point A to point B, which is the classic, the telco use case, yes, the thing which is constraining resources is fight. Here it's not the fight, it's I'm using the CPU. In this case, I'm using the storage for something else. So in those use cases, scaling up and scaling down the industry.
So here's the thing. Maybe the problem is we have 2 distinct cases. We can think of a total group, like a Venn diagram of deployments that are this size hardware-wise. But the thing that distinguishes them is whether or not they continue to function if their backhaul works. So maybe that's 2 distinct use cases. We just need to draw a line down the middle, right? So
I was thinking the taxonomy we're going to go with, is this thing primarily used for NFV use cases where the constraining resource is the pipe, or is this a general purpose computing device at the edge, which are not?
yes, and I think that's the same word to what I just said.
Yeah, those are the
So here's the thing, I'm Walmart. I'm not, obviously, but I'm Walmart. And I've given all of my customers an app where they can point it at the shelf and it says, oh, well, we're out of baby wipes, but if you go to aisle 37, you'll find a similar product or whatever. So as people walk through the store, I have to scale up compute, but all the data I need to do that compute is local. So it doesn't matter that you've dug up my fiber. So that would be an example of the second medium edge. Wow, I love the names are getting a bit long. You get the idea.
Backhaul non-proof.
Yeah. So if we distinguish those two use cases by how much the newspaper article that's written about its failure focuses on the network going away, maybe that helps.
So here's another dimension that I was thinking about. That the smaller devices it's a one-way communication. Think about it. They're gonna, the tiny little devices and the small coffee shops are gonna go back to it's a hierarchical one. Medium and large, we're starting to talk about potentially a mesh. So where these units are potentially talking to each other back and forth. At the coffee shop, generally we're going to be pushing data down.
Yeah, it's true, right? This Walmart says, oh, I'm out of baby wipes, but if you drive a mile down the road, my friend Walmart has.
Yeah, but again, that's like data plane, right?
Yeah.
We're really focusing on it. I'm mostly interested.
But so bear with me. In the medium edge, it's getting back to those small, the company with the small data centers. They want to connect those data centers from a network perspective for failover, for HA purposes. They want to do it for syncing their data across the data centers.
I could come back also to your Tesla example before.
Yes.
If you as your Tesla moves around, you may have state information on the node, and you want to pass it on to the next.
Maybe it depends on what the thing is
That's a
doing,
good question.
right? If it's just doing data crunching, like the augmented reality thing, right? We don't necessarily need to send the picture of San Francisco any further than the thing that's going to crunch, pick buildings and send it back.
But to his point, in the typical edge use case, at least from a mobile perspective, the better pattern is for the device which is moving to carry that state and give it to the place, rather than expect the thing at the other end of the wire to go over a backhaul network to the peer which is going through.
Right. It's much more robust.
It's much more robust because eventually the information is related to the Tesla, it's related to the UE, the phone in my pocket. Transferring that via the phone to the next tower is much better than having one tower go to the other tower.
So the question that's coming back here is, yeah, we agree that whatever your end device is, when it's talking to an edge, it should go to the nearest edge that's got time to service it. That's fine. But what we've been talking about here is more about control. So does that still mean I need central control, or does that mean I need,
That's what I'm saying. The distinction is because if the thing that's causing the scale up to add a Tesla app is the Tesla itself, then it wasn't the thing across the backhaul that told it to do it. It was
the Tesla's requesting.
It could be, or it could be just a.
But the Walmart example is better because the scale up is being caused by all these devices locally, the scanners generating a lot of traffic.
That's what I'm saying. You need a more full stack there if you're going to do local scale up, because you're scaling up independent of someone across the backhaul telling you to do that. So you need more control plane local.
Right.
If the reason that you would scale up is only ever something initiated from across the backhaul, then you don't really need as much control.
Yeah, I mean, you can do this. It's whether you go and ask your neighbour for a sugar or whether you go to the shops, right? Yeah, am I going and sort of saying, lend me some of your spare capacity, I'm trying you because you're the next closest?
It's how it's autonomous you need the thing to do.
Yeah. But, I mean, the other mistake here is both of these things could be true.
Absolutely. That's why I'm saying I don't think there's one answer to what does the architecture look like.
Yeah, I don't think anyone's pretending these use cases fit every possible deployment we can think of. We're trying to think of classes of deployment so that then we can.
And the probability likelihood of that deployment.
Yeah.
Because what we know is that you can put a cloud, a fully autonomous cloud in every single place, but that might be very wasteful if what you care about is not local scale control. And then we want to identify, well, can we just put a compute node there? Are there any technical barriers to being able to do that? Like, does the latency make it not work?
I apologize for walking in the middle of the conversation from the start.
Forgive
To ask a question. That's right. So to ask a silly
That's interesting. So, Raspberry Pi man is his name. I don't actually know. I'm sorry. It's called
Amaranth.
Amaranth is his name.
okay.
You have to drink.
Raspberry Pi man. I actually think that there's an interesting parallel here with service processors on server class hardware, right? I don't know what people call those, BMCs, IOs, tracks, etc. For $2, I can buy a Linux system on a chip that can run all of OpenStack, and I can just drop it on my motherboard of my set-top box or whatever, and have a full OpenStack everywhere.
Conversations that I've had include, basically here's my one RAM unit that I jam a bunch of arms in, and that serves as my control plane. And quite honestly, you can run a control computer in the same place if you're determined enough and you're careful. It can be done.
And it depends on the scale of your.
Isn't there overhead in terms of keeping that control plane up to date? For instance, I have a number of I have a large network. I have a number of images that I may want to deploy in an edge node, and those images are getting updates once in a while.
You just do what Dell does, and you just never update the draft.
So there's a difference, right? Updating the control plane is different from updating the images which are on the control plane.
Okay, so I'm talking about updating the
OpenStack
images.
deployment. So
I'm talking about updating plans. You have
So
plans running
updating
over
control plane elements, right? And I'm saying if I was deploying Comcast set-top boxes, I'm not sure I would ever do that thing. Because the only person who can talk to that thing is me down an encrypted link. So it's not like it's exposed to bad people. And if it is exposed to bad people, it's a bad person with a screwdriver who's opened the box, and I'm not going to stop that pretty much.
my
So-
question, he's asking two questions. There is the OpenStack deployment and the glance image deployment. I submit to you that I would never change the OpenStack deployment, but I might change the glance deployment.
Sure.
Yeah, I totally agree. So if we burn OpenStack into silicon you couldn't change and put it in every set-top box, that's okay. As
I
long as
think
you can
it
put your
should
different
be.
plans in.
I'm not sure that is okay, because, it only takes me tripping up one problem in OpenStack for me to want to upgrade it. So, but on the other hand, again, when I speak in experience in this particular field,
But we're going
that's
for
what you can do.
we're
You don't
going
have
for-
to do this.
we're going for the scale of whether it's possible or not. Michael is saying for a low enough control plane
Like
load,
just simply
every
not
few
bother.
days, the Raspberry Pi level of hardware would be enough to run a minimal control plane for a few compute nodes to do that. It's not that you would necessarily want to do that, but I think some people have stumbled over.
Yeah, all right. If we're flying this model, actually, maybe the better model to think of it in terms of I am willing to, for the space of 30 minutes, basically destroy that control plane and then basically reinstall the software. There are lots of ways in which you can probably compromise your service, your OpenStack service, to deliver what you're looking for.
Yeah, I think that the reason that we got down this path is because people are used to deploying an OpenStack Ansible controller, and they get 52 services, and it needs 32 gig of memory just to sit there and idle. And the point is that if you don't need all of these other projects that are names that I have no idea what they do, the actual overhead of a controller is pretty low.
And it's not all those projects, it's all there.
Okay. So the overhead is low. Now, but then if I have 1,000 of those edge nodes to manage, and I have an application that I need to deploy somewhere, and I need to find a node to add some resources to allocate to that application, who's going to do it? If I have 1,000 instances of OpenStack.
Are you treating edge compute resources as fungible as part of a cluster?
That's the issue.
That's a use case which I have not heard
Yeah.
described.
Yeah, I think it's pull, not push, right? The state of the edge node changed because a local user wanted a thing, not because someone central said, I just want to do a whole bunch of CPU intensive stuff. Find me a complex box on the run.
It's a distinction. You might have, from a central point, decided to put something on the edge, but you generally put it in a particular place on the edge so it's near to some user that you want it to be near, right? If they're all fungible, then they might as well be in one place, right? If they're all homogeneous and there's no benefit to have one or the other, then
But still, in that one case where there is one application that I want to deploy on that node where the Tesla is going,
yeah. So
who's
I
going to
know
do that? What's the scheduler that's
That's
going to
box
do that?
23J because I know, the coordinates of the Tesla, so I call up the endpoint for 23J and say, please boot me a Tesla.
It was still something unique about that node that caused that workload to end up there.
But what is the process that's going to schedule that workload to start on that node?
So
Where is the scheduler?
we've had two conversations about that so far in today. Today, like 5 minutes ago, was the idea that you go and knock on your neighbor's door and you see who needs what space. That would be peer-to-peer. You could make that work, it would fly. You have to ask yourself what happens when none of your neighbors have space, but you know, you can make something like that work. The conversation yesterday is, imagine for a second you have a bunch of OpenStack clouds distributed with location-specific properties. You know, the control planes exist. How do I have a central scheduler whose job is to responsibly find a place to work with? That one I think is more interesting in a lot of regards because it's more realistic to what we end up doing today. And there you've got to ask yourself, how do I say, firstly, how much capacity is there in this cloud in total? And secondly, do you run this workload? Can you do it? Because a workload is usually a bunch of virtual machines of different sizes. How do I know that the whole workload is going to run there rather than, for instance, getting to the last VM and discovering it
Well,
fit?
that only is a problem if they are all tied together as one cloud, right?
No, it's a problem full stop, because I've got an application of multiple virtual machines to run in a location. I need to find a location that will fit it. I can find a location with theoretically the right count of CPUs and memory, but I can still find the application that doesn't fit because they're not distributed in a way that allows it. Or alternatively, one gets stolen during the process.
I guess I'm assuming that in the Tesla case, you needed to start up on cabinet 23J period,
Yeah.
or you're not going to be able to have that optimization.
Yeah, there's the interesting thing about the Tesla case. I'm probably not running a virtual machine per Tesla. I'm probably just saying I need a teaspoon of capacity out of an application, and then it's the application's job to kind of scale it. So one step removed.
It depends, but I mean,
Yeah, they are both valid cases.
the point is whether or not running half your application on the 23J that it's going to be near, and then if there's not enough room, you can run the other half of 24J.
Yeah.
Whether or not that's useful or not depends on that.
Yes, it does. But I think,
But my question is really, is that a job for OpenStack, or should that be a job for some other project that's sitting on top of OpenStack?
That is never going to be a job for OpenStack because that's an application.
Right. It's specific to the
This
thing
is
that
not a
you're doing.
scale question. So think about the example we got yesterday of a store where you have some processing going locally and response times are getting slow. Now, rather than timing out the transaction, I'd rather push some of that processing to the neighboring nodes, even though I'm going over the wire.
But Amaranth, it might be even not when you say response times, you know, people think kilometer or whatever. It might be that like 24 people in the last minute have walked through and the sensor at the door detected they have that barcode scanner, so I'm asking the next store over to spin things up because people are going to start scanning things any second. And that's very application.
yeah, I mean, again, for something like that, practical use case would be you ask the application of the store next door for a bit of extra capacity, and the application may choose to spin up more machines
Sure.
to deliver that.
But in that case, you're not going back to a central
Well, yes.
manager that says, oh, I know about all the capacity that's in all the different stores, so I noticed this one next door is
Yes,
extra
I noticed
10.
this one is close to you and has the capacity. We might not do the central model instead.
I also think that's not a problem
No, I
for
don't
this
think so.
year, right? We're not going to be helping you do that thing for a couple of years. Let's solve the easy cases.
Well,
first.
yeah, so ultimately the
Baby
question
steps.
is here, is there anything we can do that's going to make this hard? And I don't think for any of these things we're necessarily going in the way.
I think all of these things that we've discussed so far are possible in a sensible way now.
That's good. So,
That's my real problem. I expected to come here and be told about 7 things I had to fix by Sunday.
As long as we, the thing that would be distinctly hard would be taking OpenStack and making it the control plane for an entire sort of distributed network of computers, I think.
Yeah, so sometimes the answer is don't do that, right?
More often than not, my answer is don't do that. Yes.
Right.
Don't be that for the smaller use case number one.
for the smaller use case, case number 1, it's a hierarchy, and you may or may not be a top. I would think that there'd be set regional.
The smallest use case, we said the little box is not running a full OpenStack
Right.
deployment. It's literally just the compute node,
Yeah.
which is the
It's
victim.
it's
of
not
something.
even running over compute, right? It's an IPMI target for a
There you
something
go.
like that.
It could be either, but
One of them is the ability for us to have services like, an example, heat, which can address not a single OpenStack, but multiple OpenStack deployments. Common design pattern, which I've seen in many places, which we do at Verizon, is every location is its own complete OpenStack deployment. Personally, I have a problem with this in Shrove as well, where if I want to have a distributed cluster, I cannot have Shrove talk to two OpenStacks and say, spin me up a little here and a little here. I think there's a class of services in OpenStack which need to be able to talk to multiple OpenStack deployments, which currently doesn't exist.
The things that compose lower resources should be able to do that. So
That
can
seems
he,
totally reasonable to me. I'm just not a heat developer.
can he not do that right now?
Heat cannot work.
I just want to be aware the idea that we pretend that, you know, two boxes 5 miles away and two boxes 10 meters away or 1 meter away are equivalent to each other, and we should be running services in the same way. When you've got boxes remote from each other with a WAN connection between them, you treat the network differently. If you try and keep the bandwidth down, you expect higher latency.
Sorry, I agree that there are technical differences between the two. I'm positing to you a use case where I have two racks of equipment sitting next to each other in a data center connected by a really fat pipe, which are two OpenStack deployments. And oh, by the way, two more exactly like that 10 miles down the road. I would like a class of service to be able to do something like heat, stack, create, and have in that template some resources here and some resources there.
Because you
So
might
to question your assumption, and to be fair, I've seen this and I know this happens, but just to question your assumption, why would you have those two OpenStack clusters next to each other?
hosted
with common
vendors.
service?
Hosted
Why
vendors,
would we
right, where
have
you've got
those?
two storage vendors in your data center and they charge you different, like, you know, amounts of money per byte or whatever with different, like, performance characteristics. And
No, or I've gone and bought Rackspace and Mirantis and I put them next to each other because I don't trust one vendor to not fail me. This is a large critical system.
I'll give you one more. I'll give you one more without vendors. I'll give you one more without vendors. That is a fault domain. Within a data center, I want to have multiple fault domains.
Yes.
And I want to have an application with components on A, B, C, and D.
Yeah. I'm fine with that.
Availability.
I was trying to work out, because we're talking, I mean, I agree with you saying Trove a second ago. Trove is effectively an OpenStack service, so that would be common plate between your two independent fault domains if you were providing an OpenStack service across both.
No.
But on the other hand, if you're providing an application with redundancy in multiple clouds, then that I'm not going to debate.
No, my point is, I don't know of any service in OpenStack which can concurrently address multiple OpenStack deployments. Like,
OpenStack client can.
Okay, so here's the thing. I get the microphone because I'm kind of a big deal. You're very welcome. I think you're right, by the way. I can think of lots of use cases where I'd want to be able to talk to two regions to start an app, mostly around failure domains. All right, we have exactly approximately 4 minutes and 11 seconds left. So the ask from you guys is, if you're going to deploy some sort of edge device in the foreseeable future, maybe it's 12 months, maybe it's 2 years, I don't really mind, I want you to go to this Etherpad and make sure that the thing you want to do is represented by one of these use cases. And if it's not, either, I was about to say fix the use case, but maybe that orphans other people, but make a note in the use case, you know, my use case is very much like a micro, except my machines are blue. Or if we've completely missed your class of application because, I don't know, you're putting stuff on satellites and that's somehow different or something because reactor A may fail, then put an entirely new thing in the Etherpad. In a perfect universe, you'd also put some sort of contact details there. So when we have further questions about what a set-top box looks like, we could go and talk to someone. I get that there might be proprietary information there. I propose that you create throwaway Hotmail accounts. I don't know. I don't know how to fix that. But if you can, if you want to be like, I will be the user advocate for this particular use case, that would be cool. Because I think what we actually need at this point is more concrete conversations. Do you have any last-minute shouting?
Well, my main comment is that I do intend to take these use cases and try some implementations of them and see how that scale and what the impact on the control plane is, what sort of the call flows would be for operating these things. So if anybody wants to contribute to that, if you have some ideas around that, please get in touch.
Get out of my office. Oh wait, we've got 2 minutes and 23 seconds. Anything else? No? Good? Aw, I was hoping we were done. I want an early mark.
2 minutes, you're okay. So I added one more thing at the bottom of the screen, which is I think we need to talk about the business side of things. I know, I'm a product manager. And so one of the things is I think we need to look at some of the target verticals. And I think, telco is obvious. We've been talking about that pretty extensively at this workshop, but I think utilities is another one where there's a lot of use cases that are already happening in some way. So smart meters, smart city kinds of things. I hate to bring it up, but surveillance is a big thing. Yeah, industrial IoT is another one. HVAC, smart buildings. Those are the kinds of things that I think we need to be thinking about. So it's great that we're talking about technology use cases, but I think we also have to tie them into business use cases and industry use cases, because I'm the person who has to talk to the customers and sell this stuff. I think we're done. We're done.